Alright, in this video we'll discuss about how to find the degree, the x-intercept and y-intercept of a given polynomial function. Let's start with an example. For the given polynomial functions, find the degree of the polynomial, all x-intercepts and the y-intercept. Now, in order to find the degree of the polynomial, leading term is 5x, so the degree of this polynomial is just 1. That is, we answered the first one. B, x-intercept of a polynomial is when you set up f of x is equal to 0. That means solving for 5x plus 6 is 0. Now subtract both sides. Negative 6, negative 6. So this is 5x is equal to negative 6. This implies that the x-intercept is negative 6 over 5. So this is the x-intercept of this polynomial function. And C, y-intercept. Y-intercept is when x is 0. That means, in other words, what is f at 0? So 5 times 0 plus 6, which is 6. This implies that y is equal to 6. That is the y-intercept. All right. Let's go to this one. So the first one here, to answer A, the leading term of this polynomial is x squared, so that the degree of this one is 2. Now B, x-intercept is when f of x is equal to 0, or x squared minus 2x minus 3 is equivalent to 0. So can you get two numbers that gives us the sum negative 2 and multiplication or product negative 3? Can you get two numbers? Yes, we can get, which is I can write this one as negative 3 and positive 1. So I can write this one, x squared minus 3x plus x minus 3 is 0. So this is x minus 3. This is x minus 3 is 0. Remember the method of finding the factor of a polynomial. So this is x plus 1, x minus 3 is 0, so that x is equal to negative 1 and positive 3. This is the x-intercept. Now let's do C, the y-intercept. Y-intercept means what is f at 0? That is 0 squared minus 2 times 0 minus 3. So it becomes minus 3. So this is the y-intercept, which is y is equal to, you can write this one. So remember, we can find the x-intercept, y-intercept at the degree. Now, another question is, given the following graph, for example, graph 1 and graph 2, what is the minimum degree of each of the above polynomial? Now, the degree of the minimum degree of the polynomial is determined from the turning point. That is this one. So these are known as turning points. This is turning points. So you can see that how many turning points? 1, 2, and 3. The turning point is the point where the graph has a maximum or a minimum point. So generally, the minimum degree of a polynomial from the graph, for example, graph 1, degree is equal to minimum degree turning point point plus 1, you just add. So how many turning points do we have for graph 1? We have 3 plus 1, which is 4. So the minimum degree of the first graph is 4. For graph 2, similarly, graph 2, degree is equal to turning point, turning points, let's say, plus 1. Now, the turning points are, 1, there is 2, there is 3, there is 4. So this becomes 4 plus 1, which is 5. So remember, the degree of a polynomial is turning point plus 1. Determine whether the leading coefficient of each of the above polynomial graph. Now, remember, the first graph, graph 1, you can see graph 1, let's say graph 1, goes down, so it is even down. Then you can just conclude that the leading term is the leading term, or the leading coefficient is negative. Remember our previous discussion. Now, when you come to the second graph, graph 1, graph 2, similarly, graph 2, up and down, that is odd graph. The end behavior is, on the right side down, on the left side up, right? So this tells you that the leading coefficient is negative as well. So in my previous video, you can just determine this one based on our template graph, this one, which is f of x is equal to minus x cubed. So you can see that the end behavior. So the second one has also a negative coefficient. So given the graph, you can determine the leading coefficient.